Hello, everyone. Today I'm going to talk about Angular signals mental model. And yeah, let's start. So today's topics are going to be what are signals, a simple introduction, Angular change detection with zone.js and how it works, and the mental model of Angular change detection with signals, the topic of this talk. So I wanted to ask, have you ever wondered how does this work? Like we have a counter, we click a button and that counter up there increases. While you think of that, I would like to introduce myself. I'm Enea Jahollari. I'm a software engineer. Probably you may know me from Twitter, where I tweet a lot about Angular, hype a lot about Angular. I also have started to write posts on Medium, Angular new content, Angular new features, or performance stuff. I also love open source, where I, let's say, have a library for Angular. And of course, I work with experts at Pushbase. Okay, so let's continue to topic. What are signals? A signal is a value with explicit change semantics, and that's what they say in the RFC. But we won't go into very much detail, but we'll just see them in a practical way. So creating and reading signals. In order to create a signal, we just call the signal function, and we need to pass there an initial value. And to read them, we just call them as a function, like as a function call. And in our case, we have just, let's say, called count and have logged its value. And on the console, of course, we'll see 0. We can update signals by calling set method on them. And as you can see, we have called set there, and we have console log the value, and of course, it should show 1. Or we can update them by using the update method that, let's say, accepts callback functions with that let's say gives us the current value and where we need to return a new value. And if we, let's say, log again, we will see 2 in the console. There's also the mutate method, but I'm not going to cover it. Then we have the part of deriving signals, so creating a signal from another signal. And in order to do that, we use the computed function, where let's say, it accepts a callback function, and that callback function is supposed to return, let's say, a new function that, let's say, uses a signal. In our case, it uses the count. And if we console log the double count here, let's say it will log 4. So we had 2 multiplied by 2 will give us 4. Then we have side effects. So in order to write side effects, or let's say to know when signals change, we have to use the effect function. Sorry, the effect function, let's say, accepts a callback. And that callback will be, let's say, executed every time that count changes. So in order to see this, let's say, to learn more about this, let's see in an example, we have A and B that are 2 signals. And we have an effect that console logs A and B every time they change. But by default, effect at least runs at least once. And by default, we'll see in the console that it will log A0, B2. Then let's say after some time, we change the value of 1. And of course, because now that the first signal has changed and the effect has A as a dependency, then we will see another log that will be A1, B2. Then after some time, let's say B changes, then we will see again another log that says that, let's say, logs the new value, like A1 and B3. Okay, that's pretty much about effects. One other things that we need to know is that an effect should always be used in an injection context, like in the constructor, because it depends on the destroyref, that is a new, let's say, injectable class in Angular, and helps in order to execute logic on, let's say, destruction time. Or there's another way, and it is, let's say, by passing an injector to the effect. So in order to, let's say, know the effect where to get its, let's say, destroyref reference. Then to sum up, what we learned is about signals. So like We use them for creating state. We have computed for deriving state, and we have effects for running side effects when state changes. So like knowing when to, let's say, run something. Okay, demo time. I also have added the status link for other users to see later. Let's zoom this. So as we said, we have creating signals, so we can create them by calling the signal function, and we can read their value by calling them. So as we can see, we see 0. We can update them. Okay, so we see 1. Or by using the update value, because we're changing the same signal here, we should see 2 here. So 0 plus 1 plus 1. Then we have deriving signals part. So computed returns a function that, let's say, in our case, it multiplies our count by 2. And if we log the double count, we will see 4 here. And then if we change, so when we update a signal, the signals depending on it are notified that they should recalculate when are called again in a lazily way. So if we update count and we call double count again, we don't have to do anything like setting double count to something, because it knows that the count changed. So it should now return a new value. So in our case, it's 6. It's 6 because our count is 3. Yeah, count 3, double count is 6. Then we have the side effects or the effect function. In my case, what I've done here, because as we noted, effects should always be run inside an injection context. So what I've done is this function right here, I've called this inside main.ts constructor in order for this example to work. So as you can see, we just call this function. So this means that the effect now will run inside, and let's say, our injection context here. Let's comment this thing out and see the signals part, the effect part, sorry. So by default, as we said, the effect will run at least once. And after some times, let's say after 1 second, we will see it will change, or let's say it will emit again, or it will log this thing again. Then we have also after some time, yes, exactly what we saw on the slides. Okay, back to the slides again. So that's basically a simple introduction to signals. Okay, now Angular change detection with zone.js. How does zone.js work? So basically, zone.js monkey patches almost all the browser APIs in order to get notified whenever an event happens. And because you're an Angular developer, let's think of the browser as a component, and every time this component emits something, so on any event, we get notified by it. So like a notify zone, and it gives us the event. And these events are things like set timeout, send interval, add event listener, request animation frame, like almost every browser event. And this thing right here is a list that you can find on the link that I've put below, that, let's say, will list everything that zone.js patches and knows, let's say, when this thing emit or change. Okay, so in order to understand it better, let's create a custom zone, and in order to also understand why do we need it. So we'll start by importing the library first, like import zone.js, that today is by default in Angular applications. Then what we'll do is we will fork the current zone and override one of its method in order to implement our own logic. So as we said, zone is a class that is, let's say, exposed by default when we import zone.js. Current means that we will fork the current zone. And here we put the zone name just in order to see it on the browser console. And then we have the onInvoke task that we will override here. And basically what it does is it's a function. So it has the delegate, current, target, and task arguments. And it will, let's say, invoke the task. So it will invoke the event and give us the result here. So the delegate is just the, let's say, parent zone. And here what we do is return the result. So this is just a basic implementation, but after we get the result and before we return the result, here we are able to do some custom logic that we may want. Then what this onInvoke task does is, if an event is registered inside the zone, every time it will emit, it will trigger this function. So basically this function is like the event handler of our, let's say, tasks that change, let's say our events that change. And what does it mean to register something inside the zone? Basically, it's just using this, let's say, zone that we created and calling the run method. So meaning that everything that we will run inside this callback function, it means that it will be run inside the zone, or it will be registered inside our zone that we have. So what basically we are going to do is just register a button event listener, so the click button event listener, and of course, let's say console log the update count. Now, every time that we will click on a button that we have registered inside the zone, the onInvoke task method on the custom zone that we created will be triggered. So to better understand this, let's see an example, a count component, and the first one that we saw when the talk started. So we have a count component, we have a count field and an increment method that, let's say, increases the count by 1, and we have the template, so a div with a count, and the button that, let's say, increments the count value. Okay, so don't be afraid, this is what your Angular code is underneath. So this is Ivy generated code. So this thing is created by the compiler. As we can see here, we have the count component template. So this is the code generated by Angular for your template. And here we can see that it has this if rf1, rf means that it is a render flag, and 1 means that this thing is just the creation phase of the component, and we have the element start, adding some text, element end, creating the button here, attaching the event listener. Then we have the update phase where we just, let's say, update the text here of the, in our case, it's count, context.count. So this just shows the, or let's say attaches the count field on the DOM node. And of course, we have the text interpolation for the button that we change. Okay, so in order to easily understand what all this is and, let's say, work with it, let's create a simple version of it in JavaScript. So we have the creation phase, as we saw. So we just create a div and a button. We have the create state part. So we just say let count 0, and we create a click handler function. So a button click that increases the count, so our state here, and of course logs the count. And then we create the update phase. And just like we saw, we just update the text content of the div on the button with the count here that we have. And then let's attach these things to the body of the page. And by default, we call the update phase once by default in order for the page to be in sync. Then, of course, we need to register the event listener, so the click handler. And let's see this in action. So as you can see, the DOM doesn't update, but the console log gets called. And that means that that's Angular without zone.js today. So let's use our custom zone to make it work. So as we learned before, we have our custom zone here and the onInvoke task. We can do whatever, let's say, we can add whatever logic we want to, let's say, handle after an event has happened. In our case, we want to run the update phase. And we just do it by calling the update phase method here. But there's another thing we need to do, and that's, let's say, registering our click event inside the custom zone. So our application knows that the button that we clicked, let's say, and the event happened in our zone, and we have full control over it, and whenever it emits. So let's see it in action again, and yes, that's it. DOM gets updated, console log gets called, and that is Angular with zone.js. So like a mini Angular version, because we created the code ourselves. So let's see this in action again. So here we have this app component zone. Here we have just for typings. Let's comment this out, component zone. So we have the creation phase, we have the state creation phase, the button click handler, the update phase, and everything. So if we just, let's say, move this thing here and comment this out, we will see the same thing. So the console gets updated, but the update phase isn't run because nothing is, let's say, calling it. Nothing is saying that, hey, something changed. And how Angular does it is say, okay, create a zone, and every time something changes, run the update phase. Or Angular has other concepts like marking dirty, detecting changes, and all that other things. But here I'm explaining a simpler version just for explaining it. And here, of course, we have the event registering inside zone in order to let our zone know that, hey, an event happened on something that were registered in our zone, so we need to update because, hey, something changed, we need to be in sync. And it will work the same. And of course, you may have seen on Twitter that, hey, signals are coming. What are signals? We don't need signals and all that stuff. But we will see now how signals simplify all of this. So how to not think about zones and how not to think about all this event registering all inside. Currently, today, this is done by Angular, but even Angular, let's say, can be, let's say, optimized here because this will run every time. So the update phase or the checking of the DOM will happen every time an event happens. So how can this be done with signals? So we learned that in order to create a signal, we use the signal. We pass 0 here. Instead of calling setting ++, we say update +1. Now we have the update phase. And we have these click listeners. Let's remove all the zone. We don't care about it anymore. So we learned that an effect runs every time the, let's say, signals, it depends on change. In our case, we know that count is the main, let's say, is the main signal, or let's say is the main how can I say, function that knows that this thing depends on. So we have count here. So we need also to update phase. So count, and here we also call it. So like we need to call the signal in order for it to work. And then we have the update phase that is called 1 by default. We also learned that effects run at least once by default. So what we can do is we say effect. And here what we do is we call the update phase. So we learned that effect runs 1 by default, and every time one of its signals change, it will run. Because update phase includes 2 signals in its own, so we can also move this thing inside effect just for same. Let's move this thing right here. What happens now is that this thing right here, the moment that we click on it, as you can see, updates. That, my friends, is what Angular probably will become when everything becomes signal-based. And to see how the component look like when being in signals, it will look something like this. So if we see this, we have the button click that updates the count. So the incremented updates the count. We have the update phase, or let's say the template that we have, and that is based on, let's say, signals, just like the same we have here. And then we have the click listeners that doesn't care about zone because it's just a normal click listener. And we have the state creation part, so it's just a signal. So what we can do is we can use the signal component here directly in main. It's imported. And of course, it should work the same. So the mental model of Angular change detection with signals should just be, think of the template as it's being run inside an effect. Every time a signal changes, it will be refreshed. And that's all, folks. Thanks for coming. Follow me there. Follow me on Twitter and also follow Pushbase. Thank you very much.